start with just a basic fraction. If I have a over b, some fraction, to make it negative, we can have the negative in the numerator. We can have the negative out in front. And we can have the negative in the denominator. And these are all equal fractions, all right? So your negative sign can be anywhere, right? So we can move it around if we need to. So write that down. We're going to add 1 over z minus 2 minus 3m over negative z plus 2. Okay, so to add fractions, what do we have to have? Yeah, common denominator. Are those the same right now? They are not the same because I have a positive z here and a negative z here. I have a negative 2 here and a positive 2 here. They're really close, right? But they're not the same. So what we need to do is factor out the negative sign from the denominator right here in order to make it the same. So I have 1 over z minus 2 minus 3m over. And we're going to factor out the negative sign. So when we factor out the negative sign, it affects both terms, right? So if I take a negative out of the z, we get a positive z. And if I take a negative out of this 2, we get a negative 2. So it's going to change both signs. Okay, so now I have a negative and a negative. Again, this negative sign can move to the top. But either way, because I have negative, negative, this whole thing changes to positive now in the middle. Now we have a common denominator, so it's really easy. So we have 1 plus 3m over z minus 2. All right, one more of these. So I've got 3x plus 7 over negative x minus 4 plus x minus 7 over x plus 4. So again, we've almost got a common denominator. We just need to factor a negative out of the first one. So I have 3x plus 7 over. I'm going to take out a negative sign, and that changes both of these to positive inside the parentheses. Okay, this negative sign needs to move to the numerator now in order to combine like terms. And when it moves to the numerator, you have to distribute it. A lot of people were forgetting this in past semesters when we had a negative sign in front of a fraction. It actually distributes to the entire top. Okay, so this becomes negative 3x minus 7 over x plus 4 and x minus 7 over x plus 4. Now we have a common denominator, we can add like terms. So negative 3x plus 1x is negative 2x. And negative 7 plus negative 7 is negative 14 over x plus 4. Liam, are you good? Everything okay? Okay. Okay, special right triangles. So, totally different topic. Go ahead and flip to the back of your notebook. We haven't been here in a while. I hope you guys are saving this because it will help you in your future math lives. So, the back of our notebook, we're going to keep everything that we ever needed to memorize in Algebra 2. Okay? So, page 11. Okay, so special right triangles, there are 2 of them. We're going to learn one of them today, 30, 60, 90s. So right here, we've got a triangle, and we've already got the 90-degree angle here. Across from the short side, so if this is the shortest leg, across from it has to be the smallest angle. So that's going to be 30. And this one's going to be 60. And what's special about 30, 60, 90 right triangles is that they always have the same ratios. Okay, so if the small side, if we know that, then we know that the hypotenuse is always twice the small side. Okay, always. And if we know the small side, then this height right here is always whatever this is times the square root of 3. So as long as you know one side, you can figure out the rest of the triangle. So let's just say, let's do an easy one first. Let's say we know that this is 5. Okay, the short side is 5. So if the short side is 5, the hypotenuse has to be what? 10. It's always going to be twice the short side. And if I know the short side is 5, then this side is always going to be whatever this is times the square root of 3. So 5 root 3. And then you solve the whole triangle. Okay? So let's say that I gave you, this side was 12. This time I'm giving you the hypotenuse, right? So if I know that's 12, what's the short side? It's always half of that, right? So 6. And what's the height here? Good. Okay? So eventually you'll start to memorize these. But let's try a proof. So flip back to the beginning of your notebook.
Equilateral.
Very good. This is equilateral. I like it. If it's equilateral, what are all the angles, you guys?
6.
60. 60. So if I split an equilateral triangle in half, we're going to get one of our special right triangles, because each of these will have to be 30. Okay, and if I split the bottom in half, then what is the length of each piece here? 1. Alright, so notice we already have our ratio started. I've got 1 here, and I've got 2 here, because the hypotenuse has to be twice the short side. So who can tell me right now what that's going to be, Pete?
It's just the square root of 3.
Yeah, it's just going to be the square root of 3, but I want to prove it to you. We're going to label this h, and we can prove it by Pythagorean theorem. Okay, 1 squared plus h squared equals 2 squared. So we get 4, and we subtract 1, and we get 3, and then we get the square root of 3. Okay. So we're actually going to use similar triangles, and if you can memorize this triangle, so I want you to make sure you write this triangle in your notes. 60. Kind of sloppy, okay? But there you go, okay? If you memorize just this triangle, you can use proportions to solve. So 1, 2, and the square root of 3. And make sure you've got the 30 and the 60 in there, because it is important where the angles are, right? So the 30 is always opposite the shortest side. Okay.
Smaller angle.
Yeah.
Yeah.
Smaller angle.
Good.
Okay, so even if it's not drawn kind of normal, this one's drawn sideways, so go ahead and draw that one in your notes. They're giving us the side that actually is like the square root of 3 side, so this is the hardest one to solve for. So if you memorize that other triangle that we just wrote down, that's probably easier. And I'm going to draw it the exact same way that this one's drawn with my right angle here. And that means this has to be 30 and this has to be 60. The short side is 1, the hypotenuse is 2, this height here is square root 3. Okay? If you write them side by side and draw a picture like this, it's going to be really easy to do proportions to solve. Okay? So if I want to find A, we can just write a proportion. I know this side and this side, so I can say 7 over the square root of 3. And if I want to find A, what am I going to put over here? Don't everyone speak at once. Thank you. A over 1, all right? Because we're just setting it like a proportion when you do similar triangles, right? So now I'm going to cross multiply. 7 times 1 is 7. Square root of 3 times A, so A square root of 3. And divide by square root of 3, and divide by square root of 3. Can I leave the square root of 3 in the denominator? No. So you need to rationalize it, right? Multiply by root 3 over root 3. You can do that in your head if you want to. So that's 7 root 3 over 3 is equal to A. right, you could do another proportion, but does anyone know a faster way to find b because we know something special about this triangle? Yeah, you multiply by 2. You double it. So if I double this, that would be 14 root 3 over 3. You only have to double the 14, right? It only multiplies to the numerator. You can do another proportion, but that's more work. If you know that b is twice a, you're good to go. Okay? And let's try this one. They're giving us an easy side. They're giving us the hypotenuse. The hypotenuse is always what to this short leg? Twice. So what is x equal to? 4. Okay. And then once we know this side, what about this side? Anybody know it? 4 root 3. Okay. You know x. You know the short side, just multiply by root 3. Or you can use similar triangles. Any questions?